The RoboLogix simulation package is designed to emulate real-world robotics applications such as pick and place as well as palletizing routines. RoboLogix is ideal for students as well as robot designers and engineers. It is the only robotics simulation tool to provide engineering-level simulation at an affordable price. Tradespeople such as electricians, millwrights, and maintenance mechanics will also benefit from the advanced technical skills and knowledge they can acquire using this fully functional robotics simulation tool. RoboLogix allows the user to teach, test, run, and debug programs using the robot arm and end effector. The user can visually examine the execution of programs and control algorithms while plotting instantaneous joint accelerations, velocities, and positions. In this way, the user gains hands-on robotics programming training in a safe and secure environment. This tool can be used to prototype an application without taking up valuable time on a real-world robot. Control of the RoboLogix simulation environment is provided to the user by way of the Teach Pendant style control panel. This panel allows the user to change their perspective within the environment by using the camera control buttons located on the panel faceplate. The camera buttons provide 12 different camera angles that can be used while the program is executing or during setup. Various camera angles can assist the user in acquiring target locations for use with the Save Position function. Wide-angle views are also provided, allowing the user to get an overview of the application while the program is executing. A pallet is provided for the palletizing and depalletizing pick-and-place operations. The control panel provides control of the two conveyors available in the RoboLogix environment. Forward, reverse, and stop button controls can be found on the control panel. The conveyors move product, in this instance boxes, to and from the robot's work envelope. In addition, the feed rate for each conveyor can be individually specified by the user to maximize throughput. Robot motion and gripper controls provide control over the robot for position jogging. By using the jog buttons in combination with the Save Position button, the robot can learn positions and return to them at a user-specified rate of speed. Access to the position and variable registers is also available from the control panel. The Home Position button provides a predefined starting point that can be used as a reference for program execution. The 0 button moves the robot to a location with a 0, 0, 0 reference point as an alternative to the home position. To load and run a program in the RoboLogix simulation environment, simply click on the Program button located on the control panel faceplate. The user can navigate through the list of available options by using the provided scroll buttons. Click on the line number to select the desired program from the list. Next, click on the Load button to load the program for execution. You are given the option to enter any comments pertaining to this run if desired. Comments can be entered directly into the provided text box. Once the desired comment has been entered, click on the OK button to finish loading the program. The selected program is now loaded and visible in the control panel window. To run the loaded program, return to the main panel screen by clicking on the Main button. Now click on the Run button to execute the loaded program. With the program running, the user can view the execution line by line in the control panel window. The current line of code is highlighted as it is being executed, which is a real advantage for debugging. You can return to the main control panel screen at any time during program execution by clicking on the Main button. The emergency stop button terminates the program at any time during execution. You can create a new program by clicking on the Program button located on the control panel faceplate. Next, click on the New button to create a new program file. You would then enter the desired program name in the provided text box. Click OK to finish creating the program file. The newly created file now appears in the list of available programs. Select a new program file by clicking on the corresponding line number in the Programs window. The program file is loaded by clicking on the Load button. Enter a comment if desired, or click OK to finish loading the program file. The new program now opens for editing in the Program window. Instructions can now be added to the program. Click on the New button to add a new instruction to the program file. This simple example will return the robot arm to its origin, start conveyor 1, wait 5 seconds and stop conveyor 1. The program will then terminate. Select an instruction to add it to the program. The first instruction usually starts the robot in the home position. Click OK to add the home instruction to the program file. Additional instructions are added by clicking on the New button and selecting them from the Instruction Set dialog box. In this way, a program can be created quickly and easily by repeating these general steps. Once finished, click on the Main button to save the program and return to the main control panel screen. The new program is now available in the Programs listing for loading. It can be accessed in the same manner as any other saved program. Several features are available to assist the user in optimizing any created program. Click on the Setup button on the control panel faceplate to access the System Settings dialog box. The System Settings dialog box allows the user to define the rate of all types of motion inside the RoboLogix simulation environment. Arm motion settings provide general control of motion rates for the robot arm. The dialog also provides conveyor feed rate control for both conveyors and allows the length of conveyor 1 to be specified. The rate of motion for any action can also be defined when adding the instruction at the time of program creation. These values can be easily changed to optimize throughput. Rates of motion based on varying load conditions allow the program to be tailored to simulate real-world limitations. In addition to rate of motion control, visual feedback is provided to the user during program execution. Collision detection, as well as visible damage to the product, are features that allow the user to correct any errors in the program. These visual cues, along with the ability to view the program line by line as it is executing, combine to provide for the easy debugging and optimizing of any created program. The flexibility and control provided by the RoboLogix simulation environment makes this an excellent tool for programmers to gain invaluable experience in program optimization.